Hey everyone, welcome back for another deep dive. Today we're tackling a paper that's hot off the press, really cutting-edge stuff in AI. We're talking long context, large language models, LLMs for short. You've probably heard about them.
Yeah, these LLMs can basically chew through huge amounts of text. Think of it like a library, but supercharged.
Exactly. I mean, imagine feeding an LLM all of Wikipedia
Huh?
and then a mountain of sci-fi novels on top of that. And then for good measure, why not throw in the script of your favorite show? They just devour information.
It is pretty amazing what they can do, but there is a catch. Even with all that data, sometimes they struggle to find the right information for the task, especially when it comes to more knowledge-intensive stuff, like answering your really complex question.
Right, that's what makes this paper so interesting. It's called Inference Scaling for Long Context Retrieval Augmented Generation, and it just came out a few weeks ago, October 5th, 2024. And these authors are from Google DeepMind and UIUC, so we know it's going to be good.
Yeah, they're working on a really fascinating problem: how to make LLMs better at finding the needle in the haystack. And not just by giving them more data, but by helping them think more strategically.
Okay, I love that. So the paper basically says, hey, just giving an LLM more documents isn't always the answer.
Yeah,
You can't just keep adding books to a library and expect someone to magically become a genius, right?
right. They point out that standard retrieval augmented generation methods, or ARE, they tend to hit a ceiling. Like there's a limit to how much info an LLM can handle at once, no matter how many documents you throw at it.
So it's not just about quantity, it's about quality, helping the LLM find the right stuff.
Exactly. So to address this, they came up with two new strategies: debrag and iterdrag.
Dragonator drag. Totally, those sound like something out of a fantasy novel.
Well, maybe a little. But they're actually quite clever. DRAG stands for demonstration-based RAG, and it's kind of like giving the LLM a set of examples, almost like a study guide, highlighting the important points.
So instead of just saying, hey, LLM, find something about quantum physics, you'd give it a well-structured question and answer with the right context, like what are the key principles of quantum entanglement, and how do they differ from classical physics?
Exactly. You're giving it a model to follow, a way to understand what kind of information is relevant.
Okay, so that's DRAG. What about iterdrag? Any more fantasy creatures involved there?
No dragons this time. But iterative demonstration-based RAG, iterdrag, is where things get really interesting. It's like teaching the LLM to be a detective. Break down those big, complex questions into smaller ones.
So instead of getting overwhelmed by a huge question, it's learning to say, okay, let me break this down. What are the individual pieces of this puzzle? What do I need to know first, second, third?
Exactly. It's like building a chain of reasoning, step by step, and each step informs the next.
Got it. So the LLM is not just retrieving info, it's building an argument, a logical flow. That's so cool. But did these new strategies actually work? Did they see any improvement?
Yeah, the results are really promising. What they found is that when you combine these strategies, DRAG and iterdrag, with increased inference computation, you see a big jump in performance.
Okay, hold on. Inference computation. I think we need to break that down for our listener. What does that even mean?
Well, think of it this way. Inference computation is basically how much the LLM is allowed to think. It's the computational power it uses to process info and make connections.
So it's like giving the LLM more brain power, but in a targeted way. Not just how much it can think, but how it thinks.
Exactly. And what they found is that if you allocate that thinking power effectively using do drag and iterdrag, you get almost linear improvements in performance, like saying, hey, if you think in this particular way, you'll be much better at finding what you need.
That's amazing. So it's not just about brute force data, it's about strategy and efficient use of resources.
Right. And this has big implications for how we design and use LLMs in the real world. If we can predict how well an LLM will perform based on how it's using its resources, we can start to build even more powerful, more efficient AI systems.
Okay, this is all blowing my mind a bit. So we've got these super smart LLMs that can devour tons of info, and now we're teaching them to think strategically and find the most relevant stuff. So where do we go from here? What else did this paper find?
Well, they actually went a step further. They developed a model to predict how well our RAG will perform based on different settings. This is a big deal because it means we can start to tailor these AI systems for specific tasks and resources.
Wait, so it's like a recipe for AI success. You plug in the ingredients, the number of documents, examples, reasoning steps, and it tells you how well the LLM will perform.
You got it. Powerful tool for researchers and developers who want to build the best AI for the job.
This is so cool. But I have a feeling there are some challenges too, right? There's always a but lurking somewhere. What are some of the limitations they found?
You're right, there are always challenges. Even with these advancements, LLMs still struggle with certain types of questions, especially ones that require connecting multiple pieces of info.
Okay, so it's like those multi-step puzzles where you need to figure out one thing to get to the next.
Exactly. They call this multi-hop reasoning, and it's still a big hurdle for AI.
And what about that retrieval quality we talked about? Is just getting more documents enough, or does the quality of those documents matter too?
Quality matters a lot. Even with DRAG and iterative, if the LLM is getting bad information, it's not going to give you good answers. It's like trying to bake a cake with rotten eggs. No matter how good your recipe is, it's not going to end well.
Garbage in, garbage out. We need to make sure the LLM is getting the good stuff.
Right. And this is where it gets even more interesting because they found that even with better retrieval, there's still room for improvement.
Always more to learn. Right.
Okay.
That's what makes this field so exciting. What else did they find?
Well, it turns out that even though LLMs are getting better at handling really long texts, there's still a gap between how much they can process and how well they actually use the information. They're still figuring out how to make sense of it all.
So it's like having a super fast reader who can devour an entire library in a day, but can't remember the plot of any of the books.
Exactly. And that brings us to another key area of ongoing research: long context modeling. We need to figure out how to help these LMs not just read the words, but understand the meaning and make connections across all that text.
Okay, we've covered a lot of ground here. D-drag, iter-drag, inference computation, the challenges of long context modeling. My brain is full, but in a good way.
Yeah.
I'm definitely ready for part 2. How about you?
Let's do it. We're just getting started. Welcome back. It's great to be continuing this deep dive with you. Now, remember how we were talking about LLMs sometimes making mistakes? Even with these fancy techniques like D-drag and iter-drag?
Yeah, even the best detectives have their off days, right?
Right. Well, the researchers in this paper, they actually went a step further and trying to categorize those errors. It's like they're trying to understand the LLM's thought process to see where things are going wrong.
That's fascinating. So they're not just saying, okay, the LLM messed up. They're trying to figure out why it messed up.
Exactly. And they identified 4 main categories of errors: inaccurate or outdated retrieval, incorrect or lack of reasoning, hallucination, and evaluation issues.
Okay, let's break those down one by one. First up, inaccurate or outdated retrieval. What does that mean exactly?
So basically it means the LLM is pulling in the wrong information or info that's no longer accurate. Remember how we talked about retrieval quality being important? This is where it really matters.
So it's like the LLM is going to the library but picking up the wrong book. Or a book that's so old, the information is out of date.
Exactly. And the paper gives some really interesting examples of this. Like, imagine you ask the LLM about, let's say, a recent scientific discovery, but it pulls information from a paper that's 10 years old. Not going to be very accurate.
Right, makes sense. So it really highlights the importance of having a good knowledge base, one that's reliable and up to date. You can't expect good answers if you're working with bad information.
Precisely. And this is where those iterative strategies like iter-drag can help. By breaking the question down into smaller steps, the LLM can be more precise in its retrieval. It's like having a more targeted search warrant rather than rummaging through the whole library.
So instead of grabbing any book that mentions science, it's looking for the specific book on that particular discovery.
Exactly. Now, let's move on to this second type of error: incorrect or lack of reasoning. This one's a bit more subtle.
So it's not just about finding the right info, it's about making the right connections between those pieces of information.
Exactly. It's about the LLM's ability to think logically, to process the info, and come up with a valid conclusion.
So it's like having all the pieces of a puzzle but not knowing how to put them together correctly.
That's a great analogy. And they actually found that this type of error is more common with the one-step approach, like D-drag. With iter-drag, where you have that step-by-step reasoning, you see fewer of these errors. It's like showing your work in a math problem, right? Making sure each step makes sense.
Got it. So iter-drag is more like a careful, methodical detective, while D-drag is a bit more, I don't know, impulsive.
You could say that. Now, the third category is hallucination. This one always gets a lot of attention because it's, well, a bit creepy.
Yeah, it's like the LLM's making stuff up. Like it's gone rogue, writing its own sci-fi
Oh,
novel.
not quite that dramatic. But hallucination is when the LLM generates a response that sounds plausible, but it's not actually supported by the information. It's like filling in the blanks with its own imagination.
So it's not just about retrieving and reasoning, it's about staying grounded,
Yeah.
not letting the imagination run wild.
Exactly. The paper talks about the importance of faithful LLMs, meaning they stick to the facts.
Faithful elements, I like that. But how do you actually measure that? Do you give them a loyalty test or
Me?
something?
Well, not quite. But researchers are looking at different approaches, like using reinforcement learning to reward LLMs for giving accurate responses that are consistent with the information.
So it's kind of like training a dog.
Mhm.
Reward them for good behavior.
In a way, yeah. You're teaching them what's right and wrong,
Yeah.
guiding them to make better decisions.
Okay, that makes sense. Now, what about the fourth category, evaluation issues? That one sounds pretty technical.
It is a bit technical, but also incredibly important. It basically comes down to this: how do we know if an LLM is actually doing a good job?
So it's not just about performance, it's about how we measure that performance.
Exactly. And the paper highlights some real challenges with current evaluation methods. For example, simple things like abbreviations or even just different date formats can mess up the evaluation, lead to inaccurate scores.
So it's like using a faulty measuring stick. You might think you're getting an accurate reading, but the tool itself is flawed.
Precisely. And there's another issue that's often overlooked: the concept of abstaining. Right now, most metrics don't account for when the LLM might choose not to answer. Maybe it doesn't have enough information or confidence.
So it's like forcing a student to answer every question on a test, even if they have no clue. Doesn't really give you a fair assessment of their knowledge.
Exactly. It's like punishing the LLM for being honest about its limitations.
So it sounds like there's a lot more work to be done on those evaluation methods.
Absolutely. And that's another area where ongoing research is crucial. We need better ways to assess these LLMs so we can track their progress, understand their true capabilities.
Okay, so we've gone from inaccurate retrieval to reasoning errors to the importance of faithful LLMs. But I want to circle back to something we touched on earlier: long context modeling. That seems like a really big challenge, and the paper hinted that there's still a gap between how much text LLMs can process and how well they actually use that information.
You're absolutely right. This is a key area of focus in current AI research.
So let's dive into that a bit more. What did they find about the limitations of long context modeling, and what are some of the potential solutions?
Well, one of the key findings was that even with strategies like DRAG and iterdrag, there seems to be a limit to how much context they can effectively handle.
Okay, so it's like they hit a wall,
Yeah,
even with all those fancy techniques.
exactly. They found that DRAG's performance tends to level off around 100,000 tokens, while iterdrag does better, peaking around 1,000,000 tokens.
Hold on, tokens. Can we remind our listeners what those are?
Sure. So a token is basically a unit of text. It could be a word, part of a word, even a punctuation mark. When we talk about these token limits, we're talking about how much text the LLM is processing.
Got it. So 100,000 tokens, 1,000,000 tokens.
Yeah.
That's a lot of text. But even with that much info, the LLMs seem to hit a ceiling.
Exactly. It's almost like an information overload point where they can't really process or use any more data, even with the help of DRAG and iterdrag.
So it's not just about throwing more data at the problem. It's about figuring out how to make better use of the data. It's about improving the LLMs themselves.
You got it. And this is where the research gets really interesting. There are two key areas where improvements could really lead to a breakthrough in long context modeling.
Okay, I'm all ears. What are the magic ingredients?
First, we need to improve the LLM's ability to find the most relevant information within all that text. Imagine reading a 1,000-page book. You don't need to remember every detail, just the main plot points, the characters, the big twists. It's about filtering out the noise.
So it's like giving the LLM a highlighter and saying, okay, highlight the important stuff.
Exactly. And this is especially hard when you're dealing with lots of similar documents. The LLM needs to be able to tell the difference, find the most relevant piece of info, even if it's buried in a mountain of text.
Got it. So first challenge, finding the needle in the haystack. What about the second one?
Second challenge is improving the LLM's ability to learn from long demonstrations. Remember how DRAG and iterdrag rely on giving examples? Well, if we can make LLMs better at learning from these really long examples, it could significantly boost their performance on complex tasks.
So it's not just about giving them the study guide, it's about making sure they actually absorb the material.
Exactly. It's about improving their in-context learning, specifically for those long demonstrations.
So it's a two-pronged approach. Improve how they find info and improve how they learn from that info. Makes sense.
This has been a truly mind-expanding journey so far, and I'm eager to hear what else the researchers found. Ready for part 3.
Absolutely. Let's wrap things up and see where these findings lead us.
And we're back for the final part of this deep dive. We've been exploring how researchers are pushing the limits of what AI can do with these incredible long-context LLMs. I mean, it's mind-blowing stuff. It really is. And we've uncovered some really fascinating insights about how these LLMs learn, how they reason, the challenges they face. But I think what's even more exciting is what all of this means for the future.
Totally. So let's talk about that. What are the big takeaways from this research? What makes it so significant?
Well, I think one of the most important findings is the discovery of these inference scaling laws for RIG we talked about earlier.
You mean like the idea that if you give an LLM more thinking power and you allocate it effectively, you see a performance boost?
Exactly. And those scaling laws are a game changer because they suggest that we can actually predict how well an LLM will perform based on how much computational power we give it and how efficiently we use that power.
Okay, so it's not just about building bigger and bigger models. It's about building smarter models, models that know how to use their resources wisely. Efficiency, not just brute force.
Exactly. And remember that computation allocation model we discussed. That's like a recipe for AI success, right?
Yeah, the one where you plug in the ingredients and it tells you how well the LLM will do.
Well, that model is a direct result of these scaling laws. And it gives researchers and developers a powerful tool to optimize LLM performance, really tailor it to the specific task and resources.
That's incredible. Imagine being able to custom build these AI systems for all sorts of applications. Scientific research, customer service, creative writing, you name it. It's like having a different AI for every job.
Yeah, the possibilities are really vast. And the exciting thing is the paper suggests that we can achieve some pretty impressive results even with relatively compact models, like the Gemini 1.5 Flash model, for example, as long as we really optimize how they use their resources.
So you don't necessarily need a supercomputer to tap into the power of these LLMs. Even smaller teams, smaller companies could potentially get involved.
Absolutely. And that kind of democratization of AI is a really crucial aspect of its future, because it means more people have access to these powerful tools, which could lead to, a whole wave of innovation across so many fields.
This is so exciting. But before we get totally carried away, let's circle back to those limitations we talked about. The multi-hop reasoning, the retrieval quality, long context modeling. What are some of the most promising ways to tackle those hurdles?
Well, researchers are exploring a lot of interesting approaches right now. For multi-hop reasoning, there's a lot of work being done on techniques that help LLMs break down complex questions more effectively. It's like, teaching them to think like a detective, building that chain of reasoning step by step.
Okay, so instead of getting lost in the big picture, they're learning to focus on the individual clues, the smaller pieces.
Exactly. And by learning from those smaller steps, they can really improve their reasoning abilities overall. Now, as for retrieval quality, the focus is on creating smarter algorithms. Algorithms that can filter out that irrelevant info and prioritize the most relevant documents, even when they're dealing with massive data sets.
I was like giving them a better sense of what's important, a more discerning eye, so to speak.
Right, teaching them to separate the wheat from the chaff. And then for long context modeling, researchers are exploring new architectures and training methods that allow LLMs to really capture and utilize all of that information from these vast amounts of text.
So instead of just skimming the surface, they're learning to really dive deep, understand those nuances and connections within the text.
Exactly. And one promising area is the development of hierarchical memory systems. These systems allow the LLMs to store and access information at different levels of detail, like, taking notes while you read, highlighting those key points, and creating summaries so you can remember the most important info.
It's amazing to think about how much progress has already been made in this field, just in such a short amount of time. This paper alone has given us so much to consider.
I agree. And, it not only highlights the remarkable progress in AI research, but it also really underscores the importance of continued exploration, critical thinking. As we develop these more and more powerful AI systems, it's really crucial that we remain mindful of their limitations and, always strive to understand them better.
That's such a good point. It's not just about building the most powerful AI we can, but about building AI that actually serves humanity
Yeah.
in meaningful and beneficial ways.
Exactly. And as we wrap up this deep dive, I want to leave you with this thought. The most important intelligence of all is still our own human intelligence. It's our curiosity, our creativity, our ethics that's going to guide us as we explore these incredible possibilities of AI.
That's a perfect note to end on. Thanks for joining us for this incredible deep dive into the world of long context LLMs. It's been an amazing journey, and we can't wait to see what the future holds for this technology.